atom? From which experiment was it discovered that atoms have an internal structure? When? In 1897, Sir J.J. Thomson studied the cathode rays in detail and determined the ratio of charge to the mass of cathode rays particles. The credit of the discovery of the electron is given to Sir J.J. Thomson. Second question. What are the two parts of an atom? What are they made up of? You have studied this in Standard 8. The entire mass of the atom is concentrated, centrally situated, a positively charged small core called the nucleus. The negatively charged electrons move around the nucleus in different orbits. In this picture we can see inside the nucleus protons and neutrons are there and electron is revolving around the nucleus. The nucleus consists of positively charged protons and electrically neutral neutrons. So protons and neutrons together are called nucleons. We have learned that at the center of an atom is the nucleus and that there are moving electrons in the extranuclear part. The electrons are negatively charged elementary particles. The elementary particles that make up the nucleus are positively charged protons and electrically neutral neutrons. The size of an atom is determined by its radius. Atomic radius of an isolated atom is the distance between the nucleus of an atom and its outermost orbit. This is very important. You all know how to draw a circle and how to measure the radius. So here we are talking about the atomic radius. Atomic radius of an isolated atom is the distance between the nucleus of an atom and its outermost orbit. Atomic radius is expressed in nanometers. So here we can see a few conversions. 1 by 10 raised to 9 meter is equal to 1 nanometer. Or we can say 1 meter is equal to 10 raised to 9 nanometer. So there is a table given here. This is given in page number 48 in your textbook. Approximate size of atom and molecule. Atomic radius in meters. Example, hydrogen atom 10 raised to minus 10. Water molecule 10 raised to minus 9. And hemoglobin molecule 10 raised to minus 8. Atoms are very tiny. Modern instruments like electron microscope, field ion microscope, scanning tunneling microscope enlarge images of the atom. Look at the image of an atom obtained with a field ion microscope. Field ion microscope, image of iridium atoms. Every spot in this image is an atom. Now, this we are going to discuss. This is given in 49, page number 49 in your textbook. Let's see this in detail. The atomic size depends on the number of electron orbits in the atom. The greater the number of orbits, the larger the size. For example, an atom of potassium is bigger than an atom of sodium. Let's see. For sodium Na, atomic number is equal to 11. You have studied this. And what is the electronic configuration then? Electronic configuration is 2, 8, 1. Number of orbits is equal to 3. This is potassium atom. For potassium K, atomic number is equal to 19. So what about the electronic configuration? It is 2, 8, 8, 1. The number of orbits is equal to 4. So we can see atomic radius of potassium is greater than atomic radius of sodium. So I repeat, atomic size depends on the number of electron orbits in the atom. The greater the number of orbits, the larger the size. An atom of potassium is bigger than an atom of sodium. I hope it is very clear. If two atoms have the same outermost orbit, then the atom having the larger number of electrons in the outermost orbit is smaller than the one having fewer electrons in the same outermost orbit. For example, an atom of magnesium is smaller than an atom of sodium. So let's discuss this in detail. For sodium, Na, atomic number is equal to 11. Electronic configuration is 2, 8, 1. Number of orbits is equal to 3. But number of electrons in the outermost shell is 1. You can see in this picture. For magnesium, Mg, atomic number is 12. Electronic configuration is 2, 8, 2. Number of orbits is 3. And number of electrons in the outermost shell is 2. So we can say atomic size of sodium is greater than atomic size of magnesium. If two atoms have the same outermost orbit, then atom having a larger number of electrons in the outermost orbit is smaller than the one having fewer electrons in the same outermost orbit. So that is the reason why an atom of magnesium is smaller than an atom of sodium.